Hello there, 8th graders. This is Mrs. Minowitz, and I'm here today to talk to you about air currents. So, wind is just moving air. That's all that wind is. And generally speaking, air moves from an area of high pressure to an area of low pressure. So, high pressure air is usually or generally formed in a colder area. And this is because if you stop and think about colder areas, it's going to have air that is more compacted and more dense, and this is an area of high pressure. You have those air molecules closer to each other. So colder areas generally form areas of higher pressure. Areas of lower pressure generally form in warmer areas because if there's lower pressure, there's fewer air molecules, and this is more likely to happen when you have air molecules being spread out because there's more energy, which would happen in a warmer area when you have warmer air. So the reason why air moves from high pressure to low pressure is because that things naturally like to spread out and have as much space between them as possible. This is similar to the idea of diffusion, which is, for example, like food coloring in water, it's going to spread out, or a scent in a room, it's going to spread out. So air likes to move from areas of high pressure to areas of low pressure, and when it does this, this creates wind. There are two main types of wind that we are going to talk about. The first one is called a local wind. These are winds that blow for a short distance, and they can move in any direction. Two examples that we are going to talk about are sea breezes and land breezes, and those are shown in your diagram. We're going to take a little bit of time to go through and add a few things and explain a few things from this diagram. The first one here is showing you what's called a sea breeze. And if you'll notice, this takes place during the day. It's lighter in this picture, the sun is out, and this take place when things are heating because of the sun. And it's important that we're talking about when it's heating because that impacts where we create our areas of high and low pressure. So during the day when the sun is out and heating, it is going to heat the land faster than it is going to heat the water. Land heats up faster than water does. So over here, the water, we're going to have, generally speaking, a cooler area. And because of this, we're going to create an area of high pressure. Okay. On the other side of the diagram, we have an area that gets warmer because the land is heating up faster. When that does, that warm air rises, and that creates an area of low pressure. Okay, so we have low pressure over this warmer area because that warm air rises. Because of this, we create high pressure on the right over here and low pressure on the left. And then that means that our air is going to move inward here, and this is called a sea breeze. And this is formed because of the difference in heating here creates those differences in pressure. Now the bottom part of the diagram here is showing you what's called a land breeze. And this would happen at night or when things are cooling. And this occurs because things also cool at different rates in addition to heating at different rates. So at night, okay, the area over the land ends up being cooler, and this is because land cools down faster than water. When the area over land is cooler, we get an area of high pressure. We get that air sinking because it's cool, and that creates that high pressure. On the right-hand side here over the water, this area stays warmer. It takes a lot longer to cool down water than it does to cool down land, so it's warmer than the land. And when this happens, that warm air rises, we create that area of low pressure. When we have high pressure on one side, low pressure on the other, our air is going to move, and this time it's going to be moving outward because you end up with high pressure to low pressure. So both of these are caused because there's unequal heating and cooling, which creates different areas of pressure, relatively high or relatively low, and then our air moves because of this. Now, there's a box on your note sheet that asks you about what type of heat transfer is happening here. So here we're having heat being transferred mostly through the air. It can also happen through liquid, and this is something that we've talked about before. This is convection. So in your box on there, this type of heat transfer is called convection. Remember that convection is the transfer of heat through a liquid or a gas. And this is what happens also, say, in the mantle of the Earth. There's convection currents. This is what happens in a boiling pot of water. Heat transfer through a liquid or a gas. So this is convection as well. The other type of winds that we are going to talk about are global winds. These are ones that travel over a long distance and move in a specific direction. And this is caused by what is called the Coriolis effect. Now, the Coriolis effect is this idea that once air has been set in motion, it undergoes an apparent deflection from its path as seen by an observer on Earth. This apparent deflection is called the Coriolis effect and is a result of Earth's rotation. So basically, the Coriolis effect is this idea that because when we're traveling or moving across parts of the globe, okay, long distances, like when you're in an airplane, or when we're talking about winds traveling from different parts of the globe, we have to take into account the fact that the Earth is also rotating. And because of this, things that are a straight line actually appear not to be a straight line when you observe them. So let's take a look at this. Here's one example. If you are traveling toward the equator, okay, you would, hey, I want to go here. This is like a straight line, but then you also have to take into account that this is rotating. So you would actually end up over here, okay, because your target moves. So you'd have to take into account what you're actually doing. Another example we'll show here is if you have a plane flying from Anchorage, Alaska towards Miami, Florida. If you went directly, you're going to actually miss your target because of the Coriolis effect. The target location where the plane was headed when it took off has moved with Earth's rotation, so the plane would end up to the right of its original target. So if we play this, if it didn't take into account the Coriolis effect, it's going to end up over here somewhere towards Mexico because its location is actually moved because the Earth is rotating. The same thing happens in the southern hemisphere, and the only difference is that if we're traveling towards the equator from the South Pole or the farther south, we end up being deflected to the left instead of to the right. This also impacts things like hurricanes and affects the directions that they actually spin because they're a huge system and are a large global scale. But this does not impact smaller things such as tornadoes. Tornadoes can actually spin in either direction. This also, contrary to popular belief, does not impact how things go down the drain or how a toilet flushes in the northern and southern hemisphere. That's not related to this at all, even though sometimes people will tell you it is. Clear up that misconception. So we just get this deflection because the Earth is also rotating. Some examples of these global winds are doldrums, trade winds, which are north and south of the equator. Then westerlies would be between 30 and 60 degrees north and south. Then the polar easterlies, which are near the poles. There are also jet streams, which are narrow belts of high-speed air. These dramatically impact our weather based on where they're at and where they're moving. This also explains, jet streams, why when you are sometimes in a plane and you'll notice that it takes you longer to fly. Say when I go to New York, it takes me longer to fly back from New York than it does to fly there. And one of the reasons is because the jet stream is going the opposite direction there usually, so we have to fight it on the way back versus going with it on the way there. So you also have a diagram showing where these are at. You have the trade winds, the westerlies, polar easterlies, and then you'd have some jet streams in there as well. Doldrums, it's kind of an interesting word. It comes from an Old English word that means foolish because people were considered foolish if they were caught sailing in that area, mainly because there really wasn't much for wind. And trade winds got their name because people used them to sail between Europe and America to trade. We'll talk about this more in class.